Hi, everybody. Good morning. So welcome back. Welcome back to Philosophy 101. We have another key meeting today as we wrap up the last material on the subject of time and metaphysics of time. So today we're going to move on from that at least, but we have to finish one more author. So we're going to try to go over all of that today. And then Monday we're on to the next subject, which is the philosophy of mind. So good morning to you guys. Hope you're doing well. Getting a good early start, and there's still 7 minutes till it's 9, so I'm just hanging out. But to anybody arriving for now, welcome back. Good to see you. Hope you're doing really good, and let's get this lecture in. Cool. All right, welcome there. Hello, good morning. Just getting this set up good here. Good morning, Bella. Nice to see you. Nice. Okay. As usual, anybody at any time, feel free to just toss in a comment, question, observation, recommendation. I don't know. I'm happy to hear anything. So just good to have a little interaction with you guys in this morning and talk about some cool stuff in philosophy. Hey, Elon. Hey there. Good to see you there. Hey, Emily. Good morning. Couple more minutes. Stay hydrated. All right, we're getting close. Welcome back, you guys, to all showing up. Hello, good morning. And get ready as we take another look at time for one last class period. Hey, Ellen. All right, well, it's more or less class time, so welcome back, everybody. Feel free to say hi. I'd like to see you guys say hello and good morning, but at any rate, welcome back. So today it's April 17th, Friday. This is our 9 to 9:50 class, and we are going to wrap up whatever's left over from Ted Sider. There's not much left of his work, and then we're going to try and talk briefly about the article by David Lewis called The Paradoxes of Time Travel. So this week it's all about time and the metaphysical analysis and the scientific analysis of time. Just quick review to get us back situated with the topic. Starting with Albert Einstein. So what Einstein showed is that when you say two events are simultaneous, this is relative. There's no objective fact about whether two events are simultaneous or whether they occur in a different order. And to demonstrate this outcome, he asks us to contemplate two lightning strikes that occur on two different points on a railway track. He says, suppose that those 2 points A, B, the lightning strikes occur there and that they're simultaneous. He says, what does this mean? He thinks that a person's going to have a difficult time giving any answer because you'll probably just sort of say something that is synonymous with the word, like it means same time as. But we're asking a more difficult question. How could we actually perform an experiment to test whether the two things are simultaneous? Like, what would it mean for them to be happening at the same time? And if we don't know how to test for it, maybe it's just a concept that we're using, but it doesn't really have any clear meaning. So he says this would be the best method to do it, given what we know about the transmission of light and the way that vision works. So take the distance between A and B, designate the midpoint M, place one observer that's motionless at this point M. If this observer who's at M, the midpoint, sees the two events at the same time from his vantage point, then relative to him, they're simultaneous as long as we assume that the speed of light is constant. Because under those conditions, the two light signals reached M at the same point in time. They traveled the same distance since M is equally distant from A and B. They were going at the same velocity. That's why that stipulation is important. And so if two objects arrive at a common endpoint, having traveled an equal distance at the same velocity, then they must have departed from their origin points at the same time, and that's simultaneity relative to that observer. But if we put a second observer on a train, and this train is moving through the scene in the direction toward B away from A, then as it traverses the midpoint, if the individual who's the observer on that train conducts an observation of A and B while they're passing the midpoint and while the other observer at his stationary midpoint conducts the observation, seeing them simultaneous from his position. The second observer who's in motion will not see A and B happening simultaneously because he's moving away from A towards B. And so the two light signals are going to reach his eyes at different times since they're moving at the same speed, but one has farther to go to get to him. So in the second observer's case, A and B are non-simultaneous. And we could multiply the problem to another degree by saying there's a third observer going the opposite direction and he would see A first. So basically, the two events A and B cannot be claimed with any objective fact to be simultaneous or not. It depends on the condition and velocity of the observer, and that therefore leads to all kinds of very deep and puzzling results. That all events of space-time are equally real, past, present, and future all exist, because what you call the past or future is just relative to your condition of observation. So anyways, then there was Ted Sider. Ted Sider, quickly though, we also said some stuff about the time dilation phenomenon and twins paradox. Then we'd start talking about Ted Sider. So Ted Sider says there's difficulties explaining the notion of time. Why is it so hard to explain? Because the ordinary way we talk about it is that we think time moves. We say time flies, time is marching on, time is passing, time is going slowly, quickly, it's flowing. All those different common phrases indicate that we think somehow that time is moving. But what does that actually mean? Because to actually describe anything moving, you have to say that it's at different places at different times. This was indicated by means of the example of the train. The train departing from Boston, eventually arriving in Washington, it only is able to get from point A to B because it's at different places at different times as it makes its journey. So if time is moving, then what are we saying? That time moves by being at different places at different times? Now it sounds like we're invoking the concept of time in order to ground a definition of how it moves. So that doesn't work. Also, saying the present moment moves doesn't really do any better, because if you say, at one time, present moment is 9 a.m., at a later time, the present moment is 10 a.m., well, we're still talking about the present moment moving with reference to some times, and therefore we still have this reference to time itself in trying to talk about how it moves. So he says a better thing is then just to abandon the whole attempt to say time moves and just go with Einstein's space-time theory, which according to that, there's to understand the conception of space-time that's put forward by that theory, he gave us the idea of the space-time diagram. In a space-time diagram, we show the existence of an object across its entire career, you could say, from the initiation of its existence till the end. And on such a graph, like a human being's life would be shown as having duration by being extended along the t-axis of the four-dimensional graph. Now, if you were to, let's say, talk about each moment of the object's existence as it endures across that span of time, for each single moment, there's one what is called temporal part. So a temporal part of an object is just the object at a single moment of time. Like, for example, one temporal part of you is listening to this lecture right now, but with each new moment that passes, it's another temporal part in the sequence of all your temporal parts. According to that, then, you're not fully present sitting in your chair right now. At most, one temporal part per moment is. And what you actually are as a being is the sum total aggregate of all the temporal parts stretched across the timeline that you exist in. And according to this thought, all those temporal parts are equally real. It's not just this present moment that's real, but the parts of you in the future and past, back then and ahead of you, they're all exactly as real as this current moment is. Okay, and then so after that, he wanted to discuss how, according to the theory, you have to sort of rethink about the way time is. You have to rethink of it and think of it more similar to space. And so that was where we ran out of time last meeting. We went over 3 similarities between space and time. So one of the similarities is in terms of reality, meaning that objects that are far away in space are equally real as objects that are present in space. And the same is true of time, meaning that events that are happening now, like this lecture, clearly you finishing high school, those moments, whether future or past, are just as real as you listening to the lecture right now. A second similarity was in terms of parts. Objects take up space by having spatial parts. That's like the physical parts, the different parts of it that occupy whatever space, like in your case, heads, hands, feet, in case of this table, legs, tabletop, and so on. But objects occupy time by having temporal parts. So there's that second similarity. And the third one we finished with is that they're also similar in terms of the words here and now. So basically, there's no objective reference to the terms here and now. They're both relative terms. So here just refers to wherever a speaker is when they say that, what part of space around them they are in. And now just refers to whatever time the speaker speaks the word at, but neither one has a single objective reference. So there's no like unique moment called now, nor is there a unique place called here. After that, that's pretty much the end of his article, but I wanted to tie up a few loose ends that he mentions after that. So pretty much closes from there. But what he says is some people, of course, are going to find this whole concept of space-time and the theory of Einstein to be really contrary to their common sense. And so some people, I don't know if it would be like a physicist or maybe certain philosophers, but a lot of average people might think, this is just too weird. It can't possibly be true. It's just too contrary to what my everyday common sense would think. So like, for example, he gives this quote. He says, someone might react to this entire theory in this way. Past and future objects do not exist. The past is gone. The future is yet to happen. Things do not have temporal parts. At any time, the whole object is present, not just a temporal part of it. There are no past or future parts left out. And now is not like here. The present moment is special, unlike the bit of space around the speaker when they say here. So, as the future, it doesn't happen until, we get there. And me talking to you or you listening to this lecture, it's not just like one sliver or section of the entire person's existence, but it's the whole person talking, not just one part of them. These could seem to be more reasonable or common sense. Here's another possible objection that one might make. They may say the theory of space-time is way too counterintuitive. It's too strange because according to it, nothing really changes. Okay, so let me basically go over that with you. Does anything change according to space-time theory? Not really, because in this theory, all the moments of each object's existence are equally real, and they're all laid out there in space-time. So say, for example, that you get a haircut. Before the haircut, you have long hair. After the haircut, your hair is shorter. Now, you would probably say, an ordinary person would just say, I've changed. My hairstyle has changed. It used to be long, now it is short. But according to the space-time theory, did anything really change? No, because the temporal part of the individual on that timeline with the short hair has always been on that point along the sequence. And the later temporal part of the individual with the shorter hair, I don't know if I said it right. So the temporal part, the initial point where the person's got longer hair, that's always been on the timeline. And the later part that's got the shorter hair, that's also a one temporal part that's always been in the sequence that had that feature. So you might say the whole set of temporal parts is not changing at all. It's just sitting there with all the features that it does have. You can think about the future moments of the individual as parts of like a road that have already been built, and therefore there's no real change. When you say, as you drive through the freeway, the road has changed. It used to be smooth, and now there are all these potholes. It's not really that the road has changed. It's just that you're currently at a different point along the road, which has always had these different features. So do we have to abandon the concept of change to accept the space-time theory? Ted Sider thinks that's not the worst objection to deal with, because he basically says you can still recapture the idea of change within the theory. You just have to kind of think about it a little differently. So what used to be called change could now just be called qualitative difference between different temporal parts, right? So like I'm wearing these glasses right now. Now I'm taking them off, right? So it looks like I've changed or something's changed about my appearance or my attire. But according to the space-time theory, the temporal part of me wearing the glasses was always right there in the timeline. And the temporal part of it subsequent to that, when the glasses are removed, that's always been there too. We could call it change, though, by simply saying there are different attributes among these two different adjacent temporal parts. One of them possessing glasses, the other not. And that doesn't seem to be so counterintuitive. We can still talk about change of a sort by just mentioning the difference of attributes that different temporal parts of one object have. Now, Marissa, here's your question. Does this mean that the theory suggests that we have a sort of predetermined fate in the sense that everything is plotted out for us? Yes, it does. It would imply that there's no possibility for a different course of events to play out for you aside from the one that already exists, because every event in your entire existence and every object's existence is fully real and fully determined. So, I mean, people, if you believe in God, you believe God controls everything because he's all powerful and he has a plan for everybody, right? So according to that idea, your kind of life is in God's hands too. And you got to just sort of hope for his providence and have faith in that. Because God's the one that calls the shots. He's the creator of the universe, and everything that happens within it is according to his design, right? That's a theistic idea. Now, if you're not necessarily the biggest believer or whatever in that stuff, and you just embrace like science and physics, well, according to this consensus view of contemporary physics, the space-time theory, you're also kind of powerless to change anything, because in that view, it is the laws of nature and the nature of space-time that ultimately governs the outcome of each event. So whether it is due to being captured within the space-time framework and having all your temporal parts laid out for you, or whether it is due to God being the ultimate authority of whatever happens, your life is in the hands of something bigger, according to either idea. So it's just kind of an interesting point of connection, whether seen from a secular or a more religious viewpoint. But anyway, yeah. Here's another objection that is a little bit trickier, and he does mention this. You might say space and time cannot, well, that the space-time theory cannot be correct because according to it, space and time should have real deep similarities because they're interlinked with each other. But in space, anyway, objects can move in whatever direction. Like an object can move forward, backward, diagonally, or whatever. So there's no limitations on the direction of travel in space. It can move in any which direction. But you could argue that that's not really the same with time, because time only goes in one forward direction, from past to the future, and future events cannot influence the past. So there cannot be backwards causation. Like me speaking and teaching you this can have a consequence on your performance on tests later, but your performance on the test later obviously can't have an effect on what you're doing now, or so it would seem. But if the space-time theory is true, then it should be theoretically possible for all points of space-time to have some relationship or causal influence on others. So basically, backwards causation and time travel to the past should be theoretically possible if this is true, but it seems like a lot of people think it's not. Well, there, Ted Sider claims, and this is something that we'll expand on now in today's meeting, that it's not actually inconceivable for there to be such a thing as time travel and causation from the future to the past. Although it's very weird and it's kind of science fictional and trippy, these are just weird thoughts, but they're not logically impossible. There are some consistent time travel scenarios that have been crafted in like science fiction stories that are not, at least, impossible in theory. So he just kind of bites the bullet there and he says, well, time travel scenarios are weird, but they're not actually literally inconceivable if there were the means to achieve it. So that brings us to our next author, and this is David Lewis. Okay, so David Lewis, let me just get those notes ready. Okay. So David Lewis is a great American philosopher of the 20th century. He's actually one of my favorites. If I had a personal, top 10 or whatever, he would definitely make the list. He lived from 1941 to 2001. And he wrote this paper when he was a little younger. This is the one that we're reading. It was originally spoken as a lecture in 1971. He was just 30, but it eventually got published in this form in 1976. So we'll go with that date, 1976, and it's called The Paradoxes of Time Travel. American philosopher from 1976, his essay, The Paradoxes of Time Travel. David Lewis is a great philosopher. He taught at UCLA, Princeton, in different institutions in Australia for quite a while. And he's well known for being very logically precise and sharp, but also taking and staking out a lot of unconventional kind of weird positions, but he defends very credibly and very well. So among the different interesting kind of topics that he does touch on is time. And in this paper, he wants to kind of explore the weird, puzzling paradoxes that would arise if there were such thing as time travel. And his basic thesis of this paper is a simple one, actually. He's just arguing that time travel is possible. It's possible. It's not impossible. So what he's going to try and argue is that the weird, puzzling, paradoxical aspects of the concept of time travel do not actually show that it's impossible. They just show that it's weird and strange, as you probably would expect. But they're not things that are impossibilities. So his goal in the paper is to sort of tell you why the weird, strange aspects of the concept of time travel do not contradict that it's possible. Okay? So first thing then he does is he tries to just provide a little definition of what he thinks time travel is. And this, I guess, makes some good, reasonable sense. So he says this time travel he defines it as a discrepancy between two different time frames or two different measurements of time. Okay, so it involves a discrepancy between two different time frames or two different, we could say, measurements of time. A time traveler departs and arrives at his destination over some travel time. But if he's a time traveler, then the separation in time between when he departs and arrives does not equal the duration of his journey as he experiences it. So here's a graph or a little diagram. Here's a person. Let's say this person enters this cylindrical type structure, okay? And then they emerge from it. Now, suppose that when they get in there, they have a watch on their wristwatch. And when they get into that cylinder, their watch says, I don't know, 9:20 a.m. Okay, now suppose that while they're inside the cylinder, they spend what their watch displays as 5 minutes in there. And then they get out. Okay? Now, question. This is how much time they spent in the time machine, let's call it. Well, I don't know if I want to say that. That's how much time they spent in the cylinder relative to their watch, 5 minutes. When they get out of this cylinder, okay, what if all the clocks on the walls object or whatever receptacle at 9:20 watch their watch click off 5 minutes and then emerged from it, and all the watches outside say 9:25 and so does their watch? Is that a time traveler? Did they step inside a time machine? Yes or no? If when they walked in, all the clocks said 9:20 and so did their wristwatch, 5 minutes were spent inside, and then emerging from it, all the clocks say 9:25 a.m. Did that person travel through time? Is that a time traveler? Is this a time machine in that case? What do you think? Let me hear your answer. So we're positing that they walked in at 9:20. According to their watch, that's what time it was. According to watches on all the walls and everything, that's what time it was. They spent 5 minutes within the receptacle. They exit. Now their watch and all the other watches say 9:25. Was that time travel or not? Let's see. What do you say? No, exactly. From the past to the future at a rate of 1 hour per what? Hour. Okay, so that's boring time travel. I mean, yeah, we're all time travelers, I guess, in that sense. Like, we've traveled through 22 minutes this lecture, and I guess before it's done, we'll travel through another 28. But that's not the kind of time travel that people are talking about clearly when they're talking about time travel scenarios and science fiction and so on. So in order for this person to have actually traveled through time, right, the clocks on the wall are going to have to say something other than 9:25 when he exits. The clock on his wrist will say 9:25. But let's say he traveled to the future. Then what should the clock say external to his watch when he exits from this thing after being in there for 5 minutes of personal time? They should say something that's later than 9:25. So say, for example, that he just time travels for like 3 hours. Then when he gets out of this machine, his watch should say 9:25, but all the watches outside should say 12:25, meaning that though he spent 5 minutes relative to his own experience, all the external observers outside went, that's 3 hours into the future relative to their conditions. If he went to the past, then the time shown on watches outside of his watch on his wrist should be some time that is earlier than 9:25 a.m. on that date. So if he goes into the past, then the watches outside should show something earlier in the day or even prior to that day. So like he gets out, his watch says 9:25 a.m. and all the external clocks say like 6 a.m. or 6:25. In that case, he went 3 hours into the past. So there has to be a discrepancy between his watch and all the external watches when he gets out of the machine. Otherwise, it's not a real time machine and he's just standing in a random, just empty shipping container for 5 minutes. So this then provides us with the means to point out one possible paradox of time travel. How can the same two events, so paradox alert, it's this. How can the same two events be separated by two different amounts of time? Okay, so going back to our little example here, I'll just try to draw it one more time quickly. So say when he gets in there, it says 9:20 on his watch, and he spends 5 minutes, according to his watch, in the machine. Then when he gets out, his watch says 9:25, but all the watches outside say 12:25. 12:25 according to their watch, 9:25 according to his watch. Question, how much time separates when he gets into the machine versus when he gets out? What do you think? He steps into the machine, then he steps out of the machine. But how much time is there in between getting in and getting out? It seems kind of like, in this little description, that we could give two answers. On the one hand, you might say that he spent how much time inside of the machine? One possible answer is clearly that he spent a certain number of minutes. How many minutes or how much time, we can say, according to one way of analyzing this scene. You know, he gets in, he gets out. I told you guys about how the clocks are looking. So one answer to our question, departure into the machine, arrival, emerging from the machine. How much time is separating those two events? What could one answer be? Well, you could say 185 minutes, right? They got in at 9:20. And then when he emerges, everyone that is outside of the machine seems to see him get out at whatever time that is, 12:25. But another possible answer suggests itself as well. Another way of looking at it is that it doesn't actually take 185 minutes, but he just spent how much time in the machine? Or how much time in between is obviously what? Just let me know. It's a question for you. You're gonna answer it, right? I mean, what's the answer to this question? How much time can one consider him to have spent in there, if not 185 minutes? I don't think it's too hard to say. Tell me what the answer is. What's the other possible time amount that was spent between getting in and getting out of this device? 5 minutes, exactly. So what's the real answer? Did he spend 5 minutes in it, or did it take 3 hours? It can't be both, right? What if someone told you that they took a flight from California to New York and you asked them how long did it take? And they say, okay, well, it took 6 hours and it took 2 hours. You would be like, that does not make sense. That's a paradox. That's a contradiction. Well, here's one way of resolving this initial paradox. And so this is what David Lewis says next. We can eliminate this paradox by discussing two different types of time. Okay, so how can the same two events be separated by two unequal amounts of time? Let us distinguish two time frames. Okay, so one of them is personal time, and the other one, external time. Okay, so personal time is like the time that an individual would experience personally, like the time that would be measured on the wristwatch, which is on their wrist and traveling with them. So time as experienced by the person the individual person. And it would be the kind of amount of time displayed on the watch that they keep with them as they travel. External time, though, would be time as experienced by all external observers and clocks. Time as measured or experienced by all external observers and clocks. So now with the introduction of these two different frames of time, we can actually make sense of this, seeming to be a puzzling paradox. The right way of answering this question, how can the same two events be separated by two different amounts of time, is this. Well, they can be separated by two different amounts of time because there can be the personal time experienced by the individual versus the external time, what would be measured and recorded by all the other observers and watches. So what's the answer? How much time does he spend inside the machine in personal time? This time traveler that gets in at 9:20, looking at his watch, and then emerging a certain amount of time later, how much personal time did he spend in the machine? This guy, in this example. I think you know. I just want to see. It's 5 minutes, right? Exactly. Good, Riley. So he spends 5 minutes of personal time. That's how much time he's been in there relative to his own experience. But how much external time has passed between when he gets in and when he gets out? In external time, it's been 3 hours. In personal time, it's 5 minutes. So paradox time. Why is personal time and external time basically the same in our experience? Because we can't travel through time and we can't achieve speeds of such divergent variability that we start to see time dilation effects and things like that. So our clocks basically stay in sync with each other. And therefore, 1 hour for me is an hour for you and is an hour for everybody else. But if time travel did exist and the means were available to do so, then the amount of time you experience as a time traveler would be out of sync with the external time. So if one travels to the future, then there's going to be less personal time experienced than external time when they emerge. And if it's travel to the past, then they're going to be moving forward in personal time, but backward in external time. So like if I went back to, let's say, 1970 in a time machine, and it took me 10 minutes in the time machine to get there, then I would say in 10 minutes, I'm going to be 50 years in the past. A statement like that initially sounds like a total contradiction. How can it be that in 10 minutes of future, I'll spend 10 minutes taking the journey, but in external time, time will be rolling backwards and I'll be back 50 years minus in 1970. So one way of explaining an initial paradox has been given. So we got more paradoxes, though, that he also wants to try and explain away. So this then is the first. I'm going to get rid of it. He says, based on this type of analysis, the two different time frames, we could make sense of all kinds of weird expressions. If I say to you, in about 10 minutes, I'm going to watch the Beatles perform at the roof of the Apple studio in 1969. It sounds like I'm saying something that's impossible, that in 10 minutes towards the future, I'll be 51 years in the past. But now that we have the two different units or frames of time measurement, this can be explained. So what is another possible paradox of this whole concept of time travel? Here's another one. I want to get to that. I want to make sure I'm hitting all the most important ones. So here, new question. Suppose that someone goes back in time and talks to themselves on the phone or whatever. Question, is a time traveler who talks to their previous past self, is this two people having a conversation or is it one? So Okay, there's a question. Let's think about this. It's like it's kind of in just a fun science fiction scenario. But imagine that a person goes back in time to have a little phone call or whatever with their younger self. So I don't know. Tomorrow they bring out, the Tesla time machine or whatever, and you decide that's so cool. I want to go back to before the whole coronavirus thing and warn myself about it in my younger days. So I'm going to go back to 2016, and I'm going to make a phone call to myself and just let them know what to expect. So let's say you do that. Now you're back in 2016, and you make this call, and on the other end it's you, and you're the older self, and that's the younger self, and there's this conversation happening. Now suppose that happened. What do you think? Is this two people on the phone, or is it just one? What do you think would be the best answer there, and why? Let me just hear your view. The phone call is happening between the later and the younger self, because the time traveler's gone back to the past to make the call. So how many people are on the phone there? What do you think? Is it two or is it one? It's kind of, the reason it can be sort of looked at as a paradox is because there's some basis to think both answers make sense. But I would like to see what your view is. They're both fair responses, but just give me your common sense thought, intuition on that. What do you suppose? You heard the hypothetical, right? There's a phone call ongoing between the future person who has traveled to the past to talk to their younger self and their younger self. So is this two people on either end of the phone line, or is it just one person? Okay, good. Matthew, you're giving the right answer. It's one person, but two iterations of that one person. Now, what's the term that's used for these two? You call them iterations. Well, Marissa, you're giving a different answer, so maybe deal with that. Two, because if we are defined by the sum of our temporal moments, then they each have had a different sum of temporal moments. No. It's one person, but it's two temporal parts of the same person. Okay, so one of the temporal parts is the earlier stage. Another of the temporal parts is the later stage of the same object. So in this space-time diagram, maybe I've got to make it a little further to the left so I can kind of make enough space here. So in this space-time diagram, say that the person was born in 2000, okay? And time is passing, they're just growing, getting older. But then in 2021, let's say, the time machines come out, and they decide, I'm going to take a trip back, and I'm going to go, and I'm going to have a conversation with myself in 2016. Here's 2016 along the timeline. So they go back, and they have that conversation with their previous self. After that, they take another trip back to the future, and they end up in 2021 again and continue on their life. Now, if we draw a cross-section of their space-time diagram before they make the trip back, how many temporal parts of them are in the one cross-section, just a single one? But once they make this trip back, a cross-section in 2016 will show two parts of them. The initial temporal part along the timeline as the younger person, and the later temporal part of the same person. So if you look at this zigzagging streak, this is the sort of diagram that would be shown by a time traveler. Me and you, who don't have the ability to do that, are just one of those steady advancing streaks that goes from left to right and never doubles back or loops on itself. So Marissa, it's not that there's two different temporal sequences for the one individual. This earlier temporal part and this later temporal part are both elements of the same continuous worm-like space-time structure of the individual. So the right answer, as the author would argue, is that it's actually one person, but it's two temporal parts of the person. Now, me and you, how many of our temporal parts are in space at one time? Just one. Like right now, one temporal part of me is lecturing to you, and one temporal part of you is listening to the lecture. But unless you were able to actually go back or to the future in time, There will never be more than one temporal part of you at a given moment. But say, for example, that the individual who has now gone back to 21 decides, wait, I left something behind in the 2016 year, or there's some unfinished business that I want to go back and achieve. If he makes a second trip back, then there would be 3 temporal parts of them in 2016. The initial one, the one that made one trip back, and the second one who makes a return trip. So for each return trip to the past, you're going to locate another temporal part in the same part of space. So that's the kind of answer to this puzzling question. 2 temporal parts or 2 temporal moments of the same individual are making the phone call. Now, why is that the more reasonable explanation also? Let's get into a deeper reason why. It would be better to say it's the same person rather than 2 different people, because when you have a conversation with an actual different person, you don't have memories of being that other person when you were younger. So there's psychological continuity from the future temporal part to the previous one here. This temporal part can remember being the younger temporal part receiving the phone call at an earlier moment in time. So there's psychological continuity from the future parts to the past ones. And that would indicate to us that this is not really 2 different people having one conversation. Now, to all external observers, though, it would, of course, look like it's 2 different people because you've got 2 different appearing bodies in 2 different parts, right? So how could it be one person if there's and temporal parts? And this kind of makes vivid the idea that the temporal parts are real. Okay, so let's see if there's yet another quick paradox that we can settle or resolve. See what's the next one in the list. I want to talk about these closed causal loops. Yeah, okay. So I'm just going to kind of talk you through this one. So say this happens in a weird time travel scenario. You get a call, a mysterious phone call, like you get this call tomorrow. And what the phone call is it's a person, and they're just telling you, hey, don't ask any questions. I need you to build something. Here is the instructions and the blueprint. And I'm telling you how to build this thing, and I want you to build it. So you listen to the phone call, and you're like, that's weird, but it sounds important, so I'm going to try and do it. You follow the directions to the very last detail, and you end up building a time machine. Okay, now you've got it built. Why? Because the person on the phone directed you to do it, and you did so. Based on those instructions, you built this thing. So now you have a time machine. Maybe some years pass, you let it collect dust in the garage, but then one day you're like, you know what, I'm going to try and fire it up and use it. So you do use it. And this is, let's say, 5 years from now, 2025. So you've built a time machine based on the phone call you received in 2020. 5 years pass, and you decide, let me take it for a spin. Now you use it, and you actually send yourself back to 2020. Now, what's going to happen when you go back to 2020 in this little story? What do you think? You're going back to 2020 so that you can do what there? Follow the little narrative. You got a phone call. Who knows who it's from, but they told you how to build something. Then you did build it, and you used this thing, which was a time machine, in 5 years later to go back to 2020. And the person goes back to 2020 in order to do what at that time in the past? To call your own self and tell yourself to build a machine. All right, now we've got what seems to be a little loop. How did this machine get built? Well, it got built based on information and instructions that you were given from your future self. And how did you know how to give the instructions to your past self when you became the future self? Because you just remembered the information that was given to you by your future self in the past. But where did the information come from in the first place about how to build a machine? It seems like it's just coming out of nowhere. And so that could be seen as another paradox. What David Lewis says about these closed causal loops is that although they're very weird, that they're not logically impossible, and that he says they're not even that much weirder than things that we already know are true about the universe and that are equally mind-boggling. Like, what if I ask you, this universe, has it always been here, or did it start at a certain moment in time? Either answer is kind of just bizarre. To say that it's always been here means that it's got no causal origin. To say that it came out of nothing kind of also doesn't make sense, because how can anything come out of nothing? But yet the universe, of course, does exist. So there's something about the universe and reality that seems to puzzle the mind, but we have to accept it. So he thinks the same could be true of these closed causal loops. They could be just as strange as like the question of how is it that this universe even exists? But we accept those claims. Or if you believe in God, like how is God something that exists without any origins? If it's just an inexplicable but true fact, then maybe the same could be said about the possibilities of these weird closed causal loops. Okay, so the last problem that he wants to try and explain away is this, the big question: is there any possible way that a time traveler could change the past? And a paradox also is looming there, because it seems like you could say yes or no. So he gives us this little description of a scenario where there's a guy named Tim. Now, Tim is a man who hates his own grandfather. I don't know why, but he just hates that guy. And in fact, he would like to kill his grandfather, but there's a problem. See, his grandfather's already dead. He's passed away of natural causes. But that's not good enough for Tim. He's like, I'm so hateful towards this man that I want to be the one that actually caused him to die. I would rather have I killed him. But he's already dead, so it looks like he missed his chance. Nonetheless, Tim has inherited some wealth from his grandfather's passing, and he's using that to build a time machine, okay? So Tim uses this inherited wealth to build a machine so that he can go back to like 1950 and kill his grandfather when he was back in his prime. But what's his plan? To kill the grandfather. If he does do it, then his grandfather will die before he ever met the grandmother, and therefore he would never have fathered the child that would eventually become this man Tim's parent, okay? So he's trying to kill his grandfather, but if he succeeds, then that would, I guess, prevent him from ever having been born. So now the question is raised: is it possible for Tim to kill his grandfather? Yes or no? And two answers each suggest themselves to you. On the one hand, it seems like he should be able to, because he's just there in the past, and he seems to have a gun, and he's got the motivation and the means, and he's been training, and he's very skilled. So what's to stop him? That's one way of looking at it. But another way of looking at it is that no way can he actually do this. There's no way that he'll succeed, even if he goes to the past. Why do you think someone would give that analysis of the situation? That try as he might, Tim will ultimately have to fail. Why do you think someone would say it will be logically impossible for him to kill his grandfather under these conditions? Why so? If you can sort of follow the plot line here. What do you think? Why might somebody say he's destined to fail? He can't actually succeed in this mission. Why so? This is the grandfather paradox. It's like a famous part of this paper. So, just think about a little, it's like a time travel movie, right? You're trying to go back and change something, like kill somebody that didn't get killed. But in this case, why do you think it might be claimed as in something that's impossible for him to achieve or to succeed in doing? Because if he did succeed, then he would not exist, right? Because, if he kills his grandfather, then he was never born. But how could he be never born if he's actually in the past trying to kill his grandfather? Take your own birth, okay? We all know you were born, because here you are and you're watching a philosophy lecture on time, right? Do you think there's any way that we could just cancel the fact that you were born? No, it's too late for that. You've already been born. Maybe there's things that could cause you to stop existing now, but there's no way that we can erase the fact that you were born from this universe. Otherwise, the universe would have a contradiction in it. It would both contain your birth, but it would also never have contained your birth. And that's just impossible. There's no way for a non-existent human to kill somebody, but in the event that this murder happened, the person's birth would not have happened either. So one way of looking at it is that it seems possible just because he's there. But another way of looking at it is that, of course, it's not possible, because we have a second response, that it's not actually going to be possible for him to succeed. So when he gets to the past, if he does, he'll fail in some normal way. It's not like some guardian of time will come down and like cause the whole situation to blow up. But for some basic reason, maybe his gun will jam, maybe like Mr. Magoo, the grandfather will reach down and pick up the newspaper at the last second, and the bullet will just fly over his head. Maybe he'll shoot somebody, but it's mistaken identity. Oops, and it's not his grandfather. But whatever ends up happening, it will not lead to the death of the grandfather, because as time has already played out, his survival is in 50, where the person is going back in the past. That part of space-time has always existed, just like all temporal parts have always existed. So all he's really going to do is witness the inevitable failure of his attempt, as it was destined to happen, and as it always was going to happen. So there's like another maybe, I don't know, 2 or 3 minutes on this point about the grandfather paradox. So I can easily summarize that for you at the beginning next meeting. But other than that, just continue reading through the syllabus. We're totally caught up in the dates, so you can just follow the dates through as we go on in the class. Have a good weekend, and I'm gonna get my the essay prompts ready for you guys and send those out later in the weekend, and we'll talk about them on Monday when we return. So for now, anyways, thanks guys. Have a great day. Enjoy the weekend and stay safe. And I'll see you guys back on Monday, okay? Take care.